Hello folks, today I want to talk about the object-oriented programming, and I want to say welcome with the face of this guy, the Dalai Lama, just because it creates very nice feeling for me. Okay, so I want to start first with the words the object-oriented programming is a paradigm. I will tell you the story about the object-oriented programming the way I see it. It's a story which happened far, far away from this galaxy. So, this is my story. Maybe you like it or not. In any case, I just want to explain it the way I see it. So, why do we say the object-oriented programming is a paradigm? What is a paradigm? It's a Greek word and means way of thinking. Okay, and I want to leave on the screen this beautiful picture. Usually, I imagine that I'm in this forest and I'm walking around and looking these beautiful things when I'm programming because I just want to be happy. I strongly believe that on this planet, in this dimension, we are just to be happy, not to create something or work or do something else, just to be happy. And this is my way to be happy. This is my way to fulfill my purpose on this planet. Programming makes me happy. That's all. So, we are gonna create our own world. That's why I put it here, this illustration. I imagine that when I'm doing object-oriented programming, I'm the god, I'm the king of my kingdom, and just reading the recipe, I'm creating different objects. Usually in my channel, I introduce the object-oriented programming and different concepts as a cooking show from programmers. So today we're going to cook something. And first I'm preparing the ingredients. I'm gonna talk a little bit the history of the ingredients, and after that we'll start cooking. I will show you the principles of the object-oriented programming, maybe in another tutorial if I cannot in this. But I hope you'll enjoy the show. Okay, so we are in the magical forest, and I will show you the way. I will show you different places which I enjoy very much. First, I have to tell you the history of the object-oriented programming and why it was created, as I said, in my story. The history also is a story. Nobody can travel so far back in time and see how really was. So the history is written by the victor, the guys which actually have achieved the victories, because the historians have been forced to write the history on the certain way. So in my history, in my story, actually in my fairy tale, this is how I see the thing. So back in 1967, Alan Kay, he was working in the University of Utah, was asked, "What are you doing?" And his answer was very simple. I was doing object-oriented programming. Actually, Alan Kay had a biological background, and he had a dream. He had a dream to create actually to create programs very easy, to make the programming very easy for the ordinary people, not only for the geniuses. And also he had a dream to create a personal computer with a graphical user interface, something which we get now for granted, and we cannot think for something else, most of the users. Of course there is still console, but this was the dream of Alan Kay. Also, he writes that he doesn't understand very well all the principles, but he wants actually the program to be created from objects which interact with each other, which is the most ordinary way of thinking for the people, because since we are born on this planet, since we are born on this spaceship which travels in the space, in this dimension, actually we are surrounded by objects, and our way of thinking is very close actually to objects. We can imagine how the objects actually interact to each other. So this way of thinking is close to our nature. It's very familiar to this computer which we have between our ears and we call brain. Okay, the brain likes to think with pictures, with images. If I show you 10,000 images, for example, very quickly, and the next day I will show you again the same sequence but just change few pictures, usually you will notice the new pictures. So objects, a very natural way of thinking. Of course, the objects and the object-oriented programming, we'll see, is not the only way of thinking. Armstrong, for example, says, okay, the object-oriented programming looks like something like I want a banana. Instead of banana, I get a gorilla holding banana, and behind this gorilla, I get the entire jungle. So it's a little bit overwhelming. Yagi actually has written, it came to my mind, this engineer, actually I guess this is the proper spelling of his name. Yagi, the kingdom of nouns, has written a very interesting story similar to the three block ranges, execute the kingdom, execution in kingdom of nouns. Finally I found it. So it's a very interesting story similar to the story which I'm telling, and actually he's revealing how distorted the world is in the kingdom of nouns, which is actually the kingdom of the object-oriented programming. But I actually didn't want to start with the criticism about the object-oriented programming. On another scale is a functional programming, functional way of thinking, but it just happened this way. So it's not bad that actually we started with the fact that there are another paradigms, not only this one. Functional programming like languages like Lisp, like Scheme, like Haskell, for example, which is very popular the last days, in nowadays. Okay, but let's get back to our story. So 1967, Alan Kay had this great idea, and he honestly confessed that he doesn't understand very well the whole picture of the object-oriented programming. In any case, he shares his ideas with Xerox PARC. They made him a leader of a team, and 1970 he created the first personal computer. He and his team created the first computer with a graphical user interface, with the mouse. And while they were working on this computer, they have created Smalltalk. This is one of the very popular object-oriented languages. Actually, Alan Kay was influenced by Simula 67. This is another language which purpose was to simulate the reality and create the virtual reality. So I like to be in my virtual reality in this forest. Okay, so let me tell you the rest of the story. After that, Wozniak and Steve Jobs actually saw the idea in Xerox PARC, and they have created Macintosh. We know how this story continues. Now, back in 1978, Björn Strostrup created C++, which is the object-oriented variant of C. He likes the fact that C is a very powerful language. I want to share something else with you. What if the programming languages were bots? That's something very funny. I want to share this with you. If a programming languages were bots. So here we go, Java. Everything is well organized when I'm talking about C++, by the way, not C++, but C#. By the way, I'm going to illustrate the object-oriented programming with C#. So here we go. PHP is very funny. It's a raft, but still floats, which is great. And here we go, the C. So Bjorn Strostrup actually created amphibia, if I wanna call it this way. From a nuclear submarine, he created something which even can fly. He added this way of thinking to the C programmers. Okay, so 1995 Java was created. This is a pure object-oriented programming language which encourages you, actually it forces you to use the object-oriented paradigm. 1998 Microsoft tried to create a Visual Java, but after a legal case with Stanford University Network, they have created their own version of Java. Another interesting concept of Java is the runtime, the virtual machine, which has been implemented in C# and .NET technologies as well. There we have a common language runtime. So this is a brief history. Now let's start immediately creating our world. Click here and let's play the role of this wizard. Let's create a DNA from which we are going to create objects. So our project, actually our program, should be created by objects. How that's possible? How this thing is possible? I'm going to start the Visual Studio, say new project, and start world 1. So I'm going to create my little kingdom, and I will be a king in this kingdom. Of course, each one of you which is watching this tutorial is gonna be a king together with me. Actually, we can play a god. Sorry about that. We are gonna create a DNA. Like everything in the world, first things are coming first, and the first thing is the thought, the idea of creating something. Of course, we cannot create DNA which is complex as the DNA of the human beings, but we will create models, and the models of the reality usually are simplified. They are much more simple than the real objects. So I'm gonna show you how I'm gonna simplify the things which I wanna create in my virtual reality. Visual C, console application, I don't know why it's so slow. Okay, I'm gonna create world 1, and I'm gonna use a console application because I don't want my space to be cluttered by classes, objects created by somebody else. I just want to be in control and start from the clean plane, for example. Okay, so I'm sitting on the field and I want to build my own world. Come on, Visual Studio is extremely slow on this computer. I don't know why, maybe because I'm recording. Probably you are gonna excuse me. By the way, watch the tutorial 2 times faster. Just go to the properties in YouTube when you're watching this tutorial and increase the speed, for example, 2 times. This is what I'm usually do when I'm watching the tutorials of somebody else or watching my own tutorials, because I don't have the time right now to post-process this video with Adobe Premiere or Adobe After Effects, for example, to edit and do different things. I'm not getting paid for that, so that's why I'm doing this on the fly as fast as possible. Here we go. Now we have basically 2 ways to go. We're sitting now on the junction and we have to decide which way to go. We can go one way or another way. First way of thinking. Okay, with my basic knowledge about the language, what I actually know, from programming basic, I know the primitive data types, I know literals, I know variables. I also know the operators, which do different operations and allow me to create expressions which are evaluated to values. So I know operators, I know conditional logic, I know also loops. For example, I may know, of course, arrays, functions or methods as they are called here, and that's it. Just try to create with this knowledge something like Broodwar or Warcraft, for example. Try thinking this way to create something complex world like this one. For example, the SCVs are collecting crystals here and they bring it back to the base. Different units are moving left and right and all this kind of stuff. I will even simplify the story and will give you one example with people. So usually when I'm telling you this story, I sit in front of audience and I say, for example, okay, let's say I want to create now the model of you guys. I want to create a model of persons because I'm interested, for example, of your names, your age. Very, very simple model of the reality. I'm not interested of the color of the hair, color of the eyes, for example, length, weight, whatever. Of course, as I said, the model is simplified version of the reality of this dimension. I decide which properties are important for my domain logic and I actually model them. So let's say right now I have a person which sits in front of me and his name is, let's say, John, and John is 26 years old. Procedural or structural way of thinking. I'm in the entry point of my application, which is the method main, usually in C, for example, or C++, and I want to keep track of all people of my entire audience, all persons which are sitting in the hall and listening what I'm saying. Okay, first way of thinking. As I said, I'm on a junction. I'm on the empty page right now. It's not that empty because the Visual Studio takes care of me, babysits, and creates a lot of things for me. So the first way of thinking, or structural thinking, not object-oriented thinking, is something like, okay, how can I keep, with my knowledge, the name of a person? I can keep it in a local variable. Okay, what is the type of this local variable? Oh, I have a primitive type which is string. So I'm gonna say string name1, for example, or I could call it, of course, person1 name round equals John. After that, I'm interested of his age. As you can see, are solving very, very simple problem. Integer person1, just to keep track, to be consistent. Person, of course, is small. P person age equals, let's say John is 40 years old. Okay, I want to model myself. So what I have to do, then I have to say, for example, again, string person to name equals Stoyan. This is a procedural way of thinking. Right now we will see, I will demonstrate another way of thinking, because the objects could be seen as structures, which allows me to unite a different type of variables, and on top of that to model the behavior. Okay, so integer, I will say person to age equals 52, and so on and so forth. Okay, here I see immediately the problem. I have to always drag together all these pairs of properties which I want to model. What about having more properties? For example, 10 properties. I'm interested in the color of the eyes, I'm interested in the color of the hair, I'm interested in the height, I'm interested in the weight, for example. My domain logic requires all these things. Then it becomes a nightmare to keep track of all these different variables which describe one person. This obviously it's not a way of thinking. Maybe if you know arrays, you could say, oh, why don't we unite, for example, all the names and put them in a string? Okay, let's say we are gonna do that. Instead of person 1, I will create one array, and I will say, okay, this is a string, it's array, and this array represents the person's name. It looks a little bit better, but still we have the same problem. We have to drag all these variables around together, make sure they're always synchronized. For example, on index 0 I want to be John, so on all indexes 0 on all my arrays representing different properties, I have to make sure that there are the data for John. Person's names, for example, or person's name, for example, something like that. And I could say I can even use list or whatever you like, data structure. It doesn't make any better. Okay, so probably I will comment this approach. As I said, is not very easy to think this way, is not very easy to create a program this way. So I'm gonna demonstrate right now the way of thinking which will allow me string. Let me finish this. Let's say, for example, five names. Okay, this is not a way which will make our program, our way of thinking, easy. So let's go another way. This was one direction, structural or procedural programming. Structural programming, which consists actually, the paradigm says, okay, your program should consist of methods or functions which interact with each other. It actually was a step ahead. I'm a witness of all these paradigms. Initially, I started programming back in 1983 with Apple computers, or copy of the Apple computer, something like that, with Apple Basic. And we didn't have the concept of the methods by that time, actually. So structural programming was a step ahead, but we can think differently. Object-oriented programming. Okay, it's a little bit, at least it was a little bit difficult for me, and I guess for other programmers, to start thinking differently. But once you start thinking differently, it's much easier. Okay, so now, what is our other opportunity? If the language offers you the tools for object-oriented programming, then you can do something like that. Okay, I want to model a person, and I'm interested in the properties name and age. Then, like everything in the world, first comes the idea, or first comes the plan. After the idea, there is a plan, or blueprint, which we use. After that, we give this project with this plan. We give this plan to a construction builders, and they instantiate. For example, in the architecture, they instantiate one building, one house. They can create one house from our blueprint. This is exactly the ideas in the object-oriented programming. So the object-oriented programming language gives you the structures which allow you to create objects in strictly typed languages or static languages like C#, for example. First, we have to create the project, the plan, actually, the blueprint. Also, we can create immediately object, but we will talk about this later. So instead of thinking like that, okay, in order to create Brewdorf, I have to create if, okay, what kind of a menu I have to create, how I should start, and something like that. No, this is not the way of thinking. We start by modeling the entities which will interact, the objects which are going to interact in our project. And the first thing we have to create is the blueprint for an object, usually. Of course, as I said, there are exceptions. We can create directly object without creating this project, but usually we create a blueprint. So the language, the C# and all object-oriented languages actually provide us with a syntax constructions which allow us to create the blueprint, the plan. Okay, so I click class and I will say, okay, I'm gonna model right now one person, so I'm gonna call this class person. Click add, and voila, the person was created. What I am interested is the name and the age. Each class, like every blueprint, has elements. Like a blueprint which you have on a paper, there are specific details which you have to follow to create this blueprint, so the construction builders actually understand your blueprint. After that, you hand it to this construction builders and they instantiate, they create one house from your blueprint. You can give another construction builders the very same blueprint. They will build another instance of the very same house. Of course, the houses could differ by the color or by different properties, but all these properties are owned by all these houses. So in fact, by creating this blueprint, we create a class, one set of objects which have common properties or the same properties. So initially, I'm going to show you, of course, this history. Initially, we started to model the world with the member variables, so-called member variables. Today, I'm going to talk in this lection about the elements of the class, and there are 6 elements of the class. The first element of the class is the declaration. The declaration is the keyword class followed by the name of your blueprint, in this case person, because my intention is to create object from this class. The second element is the body. The body starts from the opening curly bracket and ends with the closing curly bracket. I immediately right now can instantiate one person. I can create one person. And notice something else. In the strictly typed languages or static languages like C, you always have to first define the type of the variable in which you're gonna keep the object. By creating the class, by defining a class, we are creating a custom type. So far, in the programming basic, we know about the primitive types, which are sbyte, byte, short, ushort, int, uint in C#, of course, long, and so on and so forth. So right now we just created our own type, and we can say, okay, I want to have in my program one variable of type person, and I immediately now I can call the builders to create one instance of this class. I can say person1 equals new. This is those are the builders. With this keyword, we actually call the builders, and we say, okay, please take the blueprint of person and instantiate one person. Of course, right now our person doesn't have any properties, but as you can see, the program works. If I hit Ctrl F5, the program will start working. The objects right now doesn't manifest their presence by writing something on the console, but believe me, they exist. And usually I like to think about the objects which I'm creating as a blue pulsing spheres, like in a sci-fi movie. Why they're pulsing? Why they're spheres? Spheres probably because the sci-fi movies, and pulsing because my RAM actually needs to be refreshed very quickly, and this is the pulse of my object of my blue spheres. Okay, let's add the properties. Let's model the properties which I'm interested in. One way of doing this is by so-called member variables, or fields as they call it in Java and C#. So instead of defining right now, declaring the variables as I did in my program, I'm gonna put these variables in the body of the class. So I'm gonna say public, the success modifier, probably we're gonna talk about the success modifiers in later tutorial, public string, and I'm gonna say this is a name. So each one of my objects instantiated from this class will have a property name. And when I assign a different values, I will change the state of my object, because the set of properties determine actually the state of my object. This is the way I model the state of my object. And the behavior of my object I model by defining methods, in other words functions for the guys which are coming from the C world, which are declared and defined into the body of the class. So the next property I'm interested is integer age. And as I said, I'm gonna do refactoring. I'm gonna show you historically how did we do things, at least in my story, in my world. Okay, so right now I have two properties. I added two properties, and proudly when I create a person, I can create from this person right now Stoyan, a model of a Stoyan or John, because this newly born person, this pulsing blue sphere, actually doesn't have a name. I have a place or label where I can write his name, and also I have a label where I can write its age. But right now this person is pure creature which comes from the stars and doesn't have a name and doesn't have an age. These social labels which we stick with each one of us. Okay, so the Indians also say that only the white man gets older because the white man invented the time. So right now I have one pure person. Think of it as a baby which doesn't have a name, these social labels, and doesn't have an age. Okay, so let's make it part of our scene world. Person 1, and when I hit dot, you can see right now that I have age and name, two fields which allow me to set values and change the internal state of my object. I'm gonna say name, and let's say that this is Stoyan, and I'm gonna create John. I'm gonna create a model of John. Simplified, as I said, because we are not gods. We cannot create DNA with all its complexity. Age equals 52. Let's create another person, which is John. The same way I will create one pure person. Initially I used to call my class in my lections human, but after that I realized that actually name and age are not the properties of the human beings. The human beings have different properties. They're pure creatures, and only in the world of the men actually the name and age means something. For the nature and for the humans, they are different properties. Okay, maybe happiness. Okay, so John, let me create John right now, and after that I'm gonna say that person 2, its age is, what did I say for John? It's 40 years old. Okay, so he's younger than me, or let's use even 20. Okay, John and Stoyan, oops, sorry, I went ahead of myself. Person 2, let me copy and paste this on the next, cancel. Let me copy and paste this on the next line. But first let's create one pure creature which is gonna become John. I'm calling here the builders and I'm giving them the project, the blueprint person, and using this blueprint they are building name, they're building my John. Okay, so as a king of a little kingdom, now I want these objects to manifest their presence. See how easy it is right now for me to keep track of my objects. You can look at, as I said, the object as a data structure which collects, which holds, contents different types of data and also the actions which you want to perform on this data, but they are as a unit. I can move them as a unit. When I'm gonna give, for example, one method, formal parameter, I don't have to send, for example, the person name array or person age or whatever. Now I can send one object which contains everything what is necessary for this person to exist and do his job. Okay, so now let's say console right now right line and say my name is, and I'm gonna put placeholder here, I am years old, and let's manifest our presence. Person 1 name. I could call, of course, the variable, for example, Stoyan, because my intention is to be Stoyan, to make this pure creature Stoyan. But I just used person 1 and person 2 to emphasize the fact that this person I can make whatever I like. Okay, so let's copy and paste this in the second line and say person 2, they're self-contained, the objects are self-contained. Control F5 and voila, my friends, we see that the first person is Stoyan right now, the second person is John. Okay. While we are working this way, we notice that there is a problem with modeling by using these member variables or instance variables. I'm using a lot of terms which probably we'll discuss later, but right now those are instance variables because each one of the instances has own name, variable name, and age. That's why they're called instance variables. Instance variables. They're also called member variables because they're members of the class. We will see shortly that there are other type of member variables which are called class variables, but for that later. Member variables. Okay, so I described the second element. This actually is the third element of the class. Those are the fields. So we have declaration, we have body, and we could have fields. Fields are nothing else but variables which are declared in the body of the class. Okay, so now, as I said, we notice that exposing these member variables to the internal world is not a very good idea. Everybody could go and set the age, for example, to -52, or a value which doesn't make any sense for the property of the real world which we want to model. For example, it could be still positive, but I could say 500, which is not acceptable for my domain logic. So we cannot allow everybody from every part of the program to change the values without any critiques, without thinking about that. We need filtration, some kind of filtration or validation. So probably it's a bad idea to still keep the values of the properties in a member variables or instance variables, but set and get these values through a functions, because this is our way to check if the values are proper. So we started for each property which we want to model to use so-called mutator and accessor, or getter and setter. We still do this, for example, in Java. Okay, let me go here and show you what we did. So this is the next element of the class. This is a method. So we are going to use pair of methods to represent each one of the properties we want. So I'm going to say public string, it returns string, get name, and I'm not going to use any validation and filtration because I want to keep it simple. Return name. Also, there are other reasons to do that. I just explained one of them. Another reason, for example, is that you can have properties only for reading or only for setting, or even the value may not be kept in a field of the class. It could come, for example, from the database. There are many reasons for that, to use a pair of methods to model the property. As I said, this is done automatically even in Eclipse and NetBeans. You click with the right mouse button, you can create a property, and still in Java it's created with pair of methods as I'm introducing, as I'm showing right now. Integer, no, void, for example, void. In C# they have a naming convention to use a capital letter and a verb, but it's a capital letter, so I'm gonna type get. Here I'm gonna say set string name, and I'm gonna say here I'm using name right now, and we have here scope overlapping. This field, the name of this field, is overlapped by the local variable, because this formal parameter or parameter has the very same name. So which one prevails? In the body of the method prevails the local variable. So if we say, for example, name equals name, doesn't make too much sense. Right now C# is gonna, the ID is gonna show this with underscore, as you can see. So we are gonna use the keyword this. These tutorials are for basic. These tutorials are for beginners. Those are very basic tutorials. If we have a scope overlapping, we solve the problem by using the keyword this. This means we're pointing back to the object. I'm gonna do the same. Actually, is there something else? For the h, I'm gonna model the property with the h right now. I'm gonna say get h. I'm gonna change all this and set name, of course. Made a mistake, sorry about that. Set h, set integer h. I will repeat again, those tutorials are for beginners. H, probably I should say this in the tutorial title, or h, return h. Okay, so right now I made the changes, so I model the properties with accessor and mutator. H, get h, this is integer. That's why Visual Studio is the Mercedes of the IDEs, probably the best IDE. Of course, it's so easy if you don't do too much. Actually, the IDE writes instead of you, creates the code for you. Okay, so that's why these tutorials are for beginners. not only because of that, of course, I'm covering very basic things, concepts. Okay, so of course we have to make the fields private. This is one example of one of the 4 principles: private encapsulation. So I encapsulated the fields where I'm keeping the values of the properties, and I'm representing the properties with pair methods. Right now I cannot anymore directly set and get the values of the fields, the values of the properties represented by pair of methods. Now I can say a set and get with these methods. I'm gonna say right now for person 1, for name, we have get name, and as I said, this is the way to do it in Java. Name, and after that I'm gonna say person 1 set age, this is 52. The very same thing. I'm modeling the very same entities from the real world. I want to achieve the very same things but differently. So this is called, actually not exactly this, but improving the code without changing the functionality is called refactoring. So I'm doing refactoring right now. Okay, console. After that, getting the names also is different, because now I'm gonna use the methods get age, the very same get name, and get age. Okay, so set name, of course, sorry about that. The same thing for our person number 2. Person number 2 is gonna be John, of course, and John is 20 years old. John, a friend of mine, is not 20 years old, is almost my age, but whatever, we will say that John is 20 years old. Okay, let's run this project and we will see that nothing changes in the way the program looks from the outside world, but actually we improved the code. In other words, we did refactoring. It's better if you get used to all those terms. Okay, now as I said, even today this is how we model the entities from the world in languages like Java and PHP, for example. C# is very modern language. It was created, as I said in the beginning, 2002 actually was released, officially introduced, if I'm not mistaken, 2002. It is a successor of Java. This is the Microsoft variant of Java. It has a common language runtime, which is similar to Java runtime environment, virtual machine. This is a great idea. You write the code only once and run it on all platforms which has this common language runtime or Java runtime environment, which is just great. And the code gets compiled to something called Common Intermediate Language here, or bytecode in Java. It's a great idea. You write the code only once, you compile, and after that this compiled code can run on all platforms which actually run the Java runtime environment or common language runtime in the world of C# Microsoft. Okay, I will continue with Microsoft right now. I will stick with C# because this is what I'm using as illustration. Of course, I have lectures on Bulgarian, tutorials which are for Java, and there I'm gonna talk about Java. I'm talking in Bulgarian about Java. If there is enough interest, I may create something for Java and other languages as well. Okay, so now I have to tell you that it's a little bit cumbersome actually to use 2 methods to represent one property. Accessor mutator, accessor, mutator. In C# they have created a special syntax structure which allows us to create this setter and getter quite easily, and it comes a little bit more natural for the people. And this is what I'm gonna show you right now. So probably I should put here this, it's a common structural approach. This is what I'm gonna say here. This is an OP approach, object-oriented approach. Maybe I'll call it this way and this way. By the way, a link to all this code which I'm writing in front of you, you can find below under the movie, under the tutorial, in the description. I'm gonna put it in Pastebin and make links, so you can click on the link which you'll find in the description of the tutorial, and you'll go and see the code, so you don't have to write the code yourself. So the first approach is modeling with fields. Okay, this is the second approach, and I'm gonna call it modeling with getter and setter, pair of methods. I'm not gonna do the same for John. I'm gonna comment this as well. I'm gonna do the same here for John. The third approach, there are 4 approaches, I'm gonna show you all of them. The third approach is to use so-called properties in C#. In Java you don't have such a syntax constructor, so you cannot do it this way. So I could say, for example, public string name. Notice the syntax, get, and I'm gonna say here return name, and here I can say set name. They have a special key word here, value. So this is how I just modeled a name, the property from my real object, which I wanna create in my virtual reality. Public age. Notice also this naming convention. The property starts with capital N, and the field start or member variable starts with small n. This is integer, of course, age, and again getter and setter, return age, and here we'll say set age equals value. Great! It's much simpler, I find. This is much simpler. After that I'm going to show you the simplest approach. Okay, now if I wanna create a person1 and set the properties, I simply can say person1 name. This guy is Stoyan, and person1 capital H equals 52, and I'm gonna do the same for John. It's much simpler. Here I will say with properties 3, with properties. Nothing prevents you, of course, to keep modeling with pair of methods or even with fields. There are technologies where the people model with fields. There is no access modifiers, so we are adults, as they say, and we know what we are doing. Person2 name. The biggest advantage of the strictly typed languages is the fact that they are type saved. So you get the errors, you catch the errors as early as possible during the compilation. Here I'm gonna say John and I'm gonna say person to age. I'm gonna say John is 20 years old. This is how I set actually the properties, and this is how I'm getting them. I'm gonna copy one of those, and I'm gonna say console right line person name, age for Stoyan, and name and age for John. Okay. Now, when I run the program, it still works. I did the third refactoring, which was improving the existing code without changing the functionality. From outside, our program keeps working the very same way, but we are producing better and better code which is better understandable, and there is a principle: everybody can write a code, every dummy can write a code which the computer can understand and execute, but there are not too much people which can write a code like poetry which other people understand. And our goal is to create a code like a poetry, because this is in my world, this is what I want to do actually. I'm in this beautiful world, as I told you already. Okay, and now the fourth way which I'm gonna give you, and everybody is using it, is by using so-called automatic properties. So it's a very simple way actually of modeling. I will even comment this one and say something like that: public, and I'm immediately starting to create the properties. String name, putting here get, set, and voila, I'm done. The same, public, integer, age, get, set, and I'm done, which is just beautiful, just beautiful. In fact, what happens is Visual Studio creates a field for you which is private. By the way, if you don't put access modifier, the field or the element becomes private, except the class, which is internal. Okay, in this case, because there is no access modifier, I didn't put public, but we may talk about that in later tutorial. So in fact, what happens is the Visual Studio, or actually the compiler, creates for you a private field which is called something which we'll never guess, something like that, and puts the name, the value of the property name in this field. So what I'm gonna do here is I'm gonna stick with this way of thinking just for the tutorials I'm creating, just to show you what happens actually under the hood. In fact, I recommend you to use this automatic generated properties, auto. I'm gonna call it auto, and you'll see that everything works just before, like before. Here we go. Another refactoring. This is the fourth way, and here I'm gonna say number 4, auto properties. Auto properties. Auto properties. Okay, as I said, this is my story. Of course, there are developers which see the things differently. No offense. This is my world. Right now, I'm creating the things in my world. If you see the world differently, you can write a comment, and we can talk about that. So, as I said, those tutorials are for beginners. Private name. I'll stick with this modeling way because I wanna show other concepts as well. So that's it. Now, the next improvement of my program. Right now, what I notice is that it's quite cumbersome to create a person and set the values of the properties. There is a way, of course, there is a shortcut way with these curly brackets, and I can, for example, set properties. But what if I have also other things to calculate? We cannot see the necessity of creating a constructor, which I'm gonna reveal for you right now. But stick with this simple example right now and follow me. It's too much writing right now. I want to save this writing, and also I want to give a chance to my object to set all internal properties and to adjust itself to the environment. For example, I want to change its state at the moment it is instantiated. How can I do that? By declaring and defining a constructor. A constructor actually is a pseudo method which doesn't have a return value, and its name, it's the same like the name of my class. By the way, I just forgot to tell you that this is the property is another element of the class. It's called property and looks like that, or for auto properties they look like that. So right now let's create the constructor. I'm gonna say public person, and I'm gonna decide what formal parameters do I need. I want, when I'm constructing, when I'm actually instantiating one object of this class, immediately to be able to set the properties. In other words, the constructor helps us to set up the internal state of our objects. I'm gonna say string name, and just in case I'm gonna repeat something, the collection of the properties determine the state of an object, or I can say the set of the properties determine the state of my object, and all the methods represent the behavior of one object. And all this moves as a unit, which is very beautiful. It allows me actually to think differently, to think about my program as created by objects, and they are nothing else but data structures which contain data from different types. Okay, integer h, I'm gonna say person, and allow myself here to set the values of the properties. Now there is a big question: shall I use, for example, name, or shall I set directly the fields? There are different opinions about that. I'm not gonna start this argument, so I'm gonna say name equals name, or for my purposes, this is what I can say, of course. Name, there is no overlapping of the field and the local variable. This is one way of doing it, and because I want to set for myself a trap, which I'm gonna fall later, that's why I'm gonna say this name equals name, because there is a scope overlapping. This h equals h. Okay, as I said, I'm creating a constructor and I'm setting it this way just because later in this tutorial, or other tutorials, my later tutorials about this topic, I want to show something. Okay, so voila, right now I have two options: either to set the properties here or set them directly with the constructor. As you can see right now, the IDE shows me that there is an error. There is one error. I just created a constructor. Why I'm not able anymore to construct, to instantiate my object without giving parameters? Simply because I created a constructor. So I have to admit, and I have to tell you, that there is always constructor added to your class. if you don't do that, if you don't define a constructor, declare and define a constructor like this is added to your class by the compiler. Person. This is what Microsoft doesn't tell you. So this is actually the constructor which is added automatically, implicitly by the compiler. So it looks something like that. That's why we don't have problems in the beginning when we instantiate our objects from this class without defining any constructor. The constructor is always added to our class. In other words, there is always a constructor, implicit or explicit constructor. At the moment you define a constructor, you declare and define a constructor, this constructor is not anymore added to your class. And as a proof of that, you can see that right now the program cannot be compiled. There are errors. The IDE right now says, okay, you're trying to instantiate one object with a constructor without any parameters, but there is no such constructor defined. So if you want to continue constructing without any parameters, you have to do it manually. At the moment you add a constructor, in other words, you're telling the compiler, listen, I know what I'm doing, so don't help me, don't handle this for me. I'm gonna create a constructor. This constructor is not anymore added to your class. So I have only one option right now to give the names, because I have only one constructor. I'm gonna say Stoyan, I'm gonna say 52 years old, and here I'm gonna say John, and I'm gonna say that John is 20 years old, and my program will continue working happily without any troubles. So I continue improving the code without changing the functionality. I continue writing poetry, improving my poem right now. What if I want to have a constructor without any parameters? Not a problem. How come right now I have two methods with the same name? So I have to introduce one term which is called signature. The signature includes the name of the function, because the constructor, whatever I say about the constructor, it's valid for the methods. I introduced already the method, which is another element of the class. So in other words, the signature includes the name of the method, the type of the parameters, their number, and their order. Notice these three things. So the type of the parameter, the parameters eventually, the number of the parameters, because it could be only one or without parameters, and their order. I could create another constructor which has a different signature, and this is perfectly allowed. But to have two methods with the very same signature, this is not allowed. So right now, if I try to create another constructor like that, for example, I'm changing only the names of the formal parameters. It doesn't matter how they look, what they are. This is not allowed, because in fact I haven't changed anything. I have changed only the names of the formal parameters, but this doesn't change the fact that on first position there is one formal parameter or parameter of type string, and on the second position there is a parameter with type integer. This is not allowed because these two signatures are absolutely the same. So in other words, you can have methods with the same names but different signatures. In order to change the signature, for example, I can do something like that. Change the order of the parameters. This is already different signature, and even if the identifiers of the parameters are the same, those are two methods with different signatures. Okay, I probably will leave this as well, so you'll see what I mean. Right now I have three methods. They happen to be constructors which have different signatures, and I'm gonna show you right now how you can do a code reuse. Look at these two constructors. They do the very same thing. So I don't want to type again the same code. Can I reuse this constructor? And also I'm gonna tell you something like that by purpose. Just for example, I'm gonna say this name. Let's say when I'm instantiating one object with a constructor without any parameters, I want the name to be set to default, this word, and the age, this age equals 0. Okay. Person, this, I don't know why this this color looks a little bit different. This age and this name is equals default. Okay, so all constructors right now do the very same thing. Can I reuse, for example, this constructor which is defined in the middle? Okay, you of course can do that. You just have to type in C# this, and after that send the arguments. Notice something. Oops. Age. Oops. Name. Age. Look, I have reversed the order of age and name exactly the way as this constructor expects the parameters to be sent. I wanna tell you something else. These placeholders, I could call them placeholders, are called formal or only parameters. Formal parameters. When you send actually the literals or values for these placeholders or parameters, these values are called arguments. So here the name is an argument which I'm sending to formal parameter name, and this age goes here. Okay, so this is just perfect code reuse. I'm gonna do the same for my constructor without any parameters. I'm gonna put here this. I'm gonna send in the way how this constructor is expecting the parameters. I'm gonna say default, and I'm gonna say 0. Okay, perfect. So now, for example, I can create Stoyan 3 different ways without sending any parameters. Right now our program keeps working perfectly. I'm just improving the internal structure, name default, and I'm doing this just to show you different aspects of C# object-oriented programming, of the class actually and object, because we haven't reached the topic about the principles of the object-oriented programming. I could say something like that, 52 Stoyan, and look at this, the program continues working. The third constructor is going to be called, and on its turn this constructor is going to call this one. So I could call this constructor right now our working horse, because under the hood it's doing all the job. Working horse constructor. Okay, so let's recap. Let's see again all the elements of the class. What is the class? The class actually is the blueprint which we are using. We are giving the class to construction builders with the keyword new, operator new, to instantiate by given blueprint an instance of this class. All these objects, probably I'll draw this picture again later, this drawing. So this is the set which has been created by the class, this blueprint. And the person 1, the person 2 are objects of this class, of this set. This is a set of identical objects which has an internal state. The state is determined by the values which we set to the properties. Okay, so the class, this is the declaration of the class, those are the fields, this is the second element of the class, this is the body, this is the third element which is the field, the fourth element is the property, the fourth element, this is the fifth element is the constructor. And now I have to introduce to you, I already did it by purpose, not by purpose, but I have been forced to do it. I already introduced to you the methods, but let me show you a different perspective for the methods. Look at right now who is doing the job for our persons. Okay, our persons are, how to say that, they cannot speak, they cannot do anything. They exist in our virtual reality, but they don't have any type of behavior. They cannot do anything. So for example, how the things are looking right now. So the person 1 enters the room, the person 2 enters the room. They don't even know how to enter the room, but let's say somebody brings them into the room. And my main program, which is called class program, and my main method actually, which knows how to do something, introduces them, because the methods actually represent the behavior. They can do different type of executions. Our persons just stay still and don't do anything. So my main method looks their labels, in this case those are the properties, and says, oh guys, look at here, my name is, and he reads the label and says, oh, the name of this guy is Stoyan, the name of this, his age is 52 years old, and he does the same for John. So our objects right now don't know how to do anything, so let's teach them to introduce themselves. And many people can say, okay, why don't you overwrite, for example, the method to string? I'm not gonna do this by purpose. By the way, I have to come back and show you something else as well. I have to introduce another term which is called overloading. So I have to step back, unfortunately, before I teach my guys to speak and introduce themselves. So look at here. We have different methods with the very same names and different signatures. When you have more than one method in the body of the class with the same name but different signatures, this is called, this is a term, this is called overloading. Overloading the method. We have 3 different methods with the same names and different signatures. So overloading is possible if the methods have different signatures. Okay, so let's get back now to our methods. Now we want to teach our objects to do something, and to do this, notice also something else, how these objects are presented. There is the same code which we repeat over and over again. If we have to introduce our objects again in a different branch of the program, we would do the same probably. And just imagine the situation when somebody comes and says, hey, listen, I want everywhere in the program our guys to introduce themselves differently. I want first they to say their age and after that their names, or something like that. So you have to go through entire program, dig deeper into your program, and change everywhere where the objects actually gets presented. Okay, so let's teach our guys to do something, and I'm gonna do this public void. This is a very oversimplified tutorial and example, so please don't criticize that it's done by purpose. I know it should be done differently. It could be done differently and much better, but for the educational purposes, probably it's clear enough. My goal here is not to write the best program, just to represent the terms and the concepts as much as possible. Okay, so void, and I'm gonna introduce your self is the right, but I'm gonna put self here like that. Excuse my English, pardon my English, as they say. Okay, so what I'm gonna say here is console write line. I'm gonna do other mistakes by purpose as well, just to show different concepts. Okay, so now I'm gonna say console write line, and by purpose I'm gonna copy and paste this way we represent our guys. And here, by purpose again, I'm gonna use name. I'm gonna use fields instead of properties. Probably the right way to do it is always to use the properties, because behind the properties there are methods, and eventually in these methods we have filters, validators, or even some of the properties may not have fields which correlate to them. The data could go directly to the database, or you can extract the data from the database. Okay, so let me back off again and show you this. You could have properties which don't have any fields to keep their values, and for example, balance. Let's say we want to calculate the balance of our objects in our little kingdom. I will say double balance. Here I'm gonna show you get. The balance is something that gets calculated. So this is a property which gets calculated, and let's say it's based on the age multiplied by a magical number. Don't ask me why, 2.56. But as you can see, you cannot set this property. Each one of our objects will have a balance which is only for reading, but you cannot say how much. You cannot set, of course, the balance. This is the proper way how the bankers actually calculate our balances. This is a joke, of course, but Dow Jones and other very complicated coefficients could be put here, or whatever you like, of course, just to make it more serious. In my world, this is just a joke, the way they calculate these values. In any case, when they give you the balance, you don't know what stays behind, and if you try to understand, I doubt that you will understand it. Anyway, so this is our virtual world. As I said, this is one world which is far, far away from here in another galaxy, or maybe in another dimension. And in these dimensions, this is how the guys calculate the balance. Okay, and vice versa. You could have, for example, here private double. Again, you'll have a member variable or instance variable which is private, which we are gonna use for example, which we could use to transfer data from one method to another, or use as a temporary variable where we keep data from some kind of a calculations, and after that we use these calculations in another we use this value in another method. It doesn't matter. In any case, this temporary variable doesn't have corresponding property, because it's not a type of the model which we are trying to create. Right now we set which properties we are interested in, and temp, it's just a member variable which is a helper which helps the internal structure of our class to do something. Okay, so let's go back again. Now we just learn we teach actually our objects to represent themselves. Now we don't even have to say that. We don't even have to know the objects. We don't have to know their properties. We can say, for example, person 1, introduce yourself. And our person will introduce himself. Person 2, introduce yourself. This is one of the ideas of the object-oriented programming. In other words, we encapsulate inside of one data structure, which is object, our data and all the operations which we exercise over this data. This moves as a capsule, as a unit, and it's very easy now to imagine that this is one entity, something from the real world. It creates a model of the real world, of course, simplified model. Those are different viewpoints of the very same thing. It's objects in the object-oriented programming. And there is another reason to use the object-oriented programming. Nowadays, actually, we shift a little bit the focus from modeling the real world into the fact that object-oriented programming allows us to do a code reuse. Look at this. I show it to you, all the concepts, all the aspects, all the different viewpoints. So this method helps us to do code reuse. We don't have to anymore write everywhere in our application calls a write line and the very same code. We put the code in only one method, which is inside of our class, and we solve our issue. Right now, if somebody asks us, okay, why don't you change the way our objects represent themselves or introduce themselves, I will go on only one place in my entire program and change this method. This method also, you can look at this method and say, okay, this method models the behavior of our object. I teach my object to introduce himself. Control F5 and you'll see that our program didn't change at all from the user standpoint of view, but we did refactoring, we improved a lot. Okay, so this tutorial actually became very long, but I hope that you understood the ideas which stay behind all these ideas, behind object-oriented programming. Let me do a short recap. So we said that Alan Kay back in 1967 came up with the idea about object-oriented programming. Object-oriented programming is another paradigm, way of thinking, if you want to say that. It's a template for thinking. Okay, there was a structural, or there is still structural way of thinking. So object-oriented programming gives you another way of thinking, and your program is built by objects which interact with each other. In order to create an object, usually in the stricter type languages, you probably know that, or static languages, you probably know that there are loosely typed or dynamic languages. I'm not going to talk about the loosely typed languages right now, even though I love them as well. So the strictly typed languages, usually for the strictly typed languages, you have to draw first a blueprint in order to create an object, to instantiate one object. And this drawing actually has elements. The first element is the declaration of the class. The second element is the body of the class. The third element is the field or member variable or instance variable. In the next tutorial we're going to talk about the class variables. We have also in C# properties. This is the fourth element. The fifth element are the constructors. The constructor is a pseudo method because it doesn't have a return value and executes only one when we instantiate object of this class. Also, the constructor usually sets the internal state of the object, does some calculations or whatever is necessary, and the sixth element of the class here is the method. This is a function for the C programmers which is declared and defined in the body of the class. So those are the six elements of the class, and that's it for this tutorial, I guess. I will continue with the static elements of the class. Each one of those elements of the class, except the body, could be declared static. I hope maybe this was helpful. See you soon.